Greetings! I'm back for part 2 of my data virtualization series, data virtualization operators. These are the topics I'm going to cover today. 1. Recap on the use case. 2. Virtual database. What is it? 3. Translators. 4. The data virtualization operator. 5. Virtual database construction and interaction. Now let us recap the use case. Single view on multiple databases. I already described this particular use case in detail in the last video, so I'm not going to repeat myself. All I'm going to do is to summarize what I'm going to do. You can see that the current data is stored in one database, and the old data is stored in another database. What I'm going to do is use data virtualization to make the data appear to come from a single database instead of two different databases, so that the applications can just interact with one database to get all the information, namely the virtual database. Before I get started, let's look at what a virtual database is. When you use data virtualization to create a solution, the end product is always a virtual database. So what is a virtual database? You can think of it as a metadata store for components used to integrate data from multiple data sources. A virtual database typically contains multiple schemas. Each schema contains the metadata for tables, procedures, functions. There are two types of schemas, namely foreign schemas and virtual schemas. A foreign schema represents external or remote data sources, such as a relational database, a CSV file, a web service. A virtual schema is a logical schema layer that is defined using schema objects from foreign schemas. For example, you may create a virtual view table that aggregates data from multiple foreign tables from different external sources. Your virtual view ends up as a part of a virtual schema. You can see in this particular virtual database, you have actually 3 foreign schemas talking to 3 different external data sources: API, Amazon S3, and database. In order for the virtual database to talk to an external data source, you need a translator. A translator is a component that provides an abstraction layer between the data virtualization query engine and a physical data source. The translator knows how to convert query commands from a data virtualization engine into source-specific commands and execute them. The translator also has the intelligence to convert data that the physical source returns into a form that the data virtualization query engine can process. For example, when working with a web service translator, the translator converts SQL procedures from the data virtualization layer into HTTP calls, and JSON responses are converted to tabular results for the data virtualization query engine. Here are some of the translators that come with data virtualization. Amazon S3, which allows you to access objects inside the S3 storage. For example, JSON files, CSV files, XML files, etc. File similar, but they reside on the file system instead of in Amazon S3. JDBC, there is a long list of relational databases supported: Microsoft Excel, MongoDB, olldata, OpenAPI, Salesforce, Web Service, and SOAP Web Service. Now we come to the topic for today, the data virtualization operator. What I'm going to show you later on is to how you can create a virtual database using the data virtualization operator. All you have to do is define a virtual database in a YAML file. And a virtual database is defined using SQL MED. MED stands for Management of External Data. It is a part of the SQL standard that deals with how a database management system can integrate data stored outside the database. Once you have defined a virtual database, then the data virtualization operator will take care of the rest. Creation of the virtual database by preparing a Maven project, generate Spring Boot code, and include a property file. Building of Spring Boot UberJar artifacts, creation of an image using S2I, deployment of the image on OpenShift, and last but not least, creation of a route or route for external virtual database access. Next, I'm going to show you how data virtualization operator works. Before I get started, I need to prepare some external data in external databases. I am using two databases, a Postgres and a MySQL, and they both have the same schema, and each database only contains 3 entries for that part, well, in that particular table. And in the demo later on, you'll see that when I query the virtual database, you'll see all these 6 entries in total instead of 3. This demo assumes you have used the OpenShift console before. To use the data virtualization operator, you have to install it first. And to install an operator, you need an account that has cluster admin role. I'm using such an account here. I already logged in. To install the data virtualization operator, you click on operator and then enter data virtualization and then select this one here. Click on install and then you select project that you created using a normal user. In this particular case, I'm going to use DV10. And then click on subscribe and they will install the data virtualization operator. It may take a couple of minutes, but since I already have installed it in another project, so I can cancel and just use that one. First of all, I select the project and then click on the installed operator. You can see I already installed a couple of operators here, so I click on data virtualization operator. Click on virtual database. You'll see that there are already 3 virtual databases. So to create one, all you need to do is to click on the create virtual database. And it will give you the definition of some virtual database. First of all, you need to change the name of your database. For example, you're going to call it DV Demo 2, for example. And you see that there is already have a virtual database defined here. What you need to do is to open the DDL file I created in the link below this video, which points to my GitHub. You copy and paste that in here. You just select the whole thing and paste it here. As I said earlier, in order to define a virtual database, you need to use SQL MED. MED stands for Management of External Data. You see that in here is defining some foreign database schema, wrappers, etc. So this is using the SQL MED commands. So I'll have another link which points to the commands that are available to you. And the main thing here is this one here. This is creating your virtual schema or virtual table in this particular case. And then the next thing you need to do is provide the information as to how you're going to log into the relational databases. So in here, my Postgres is set up as is described here, but I need to include the MySQL definitions in there. So what I need to do is to, again, cut and paste. And that is all is required. Then you click create, and then off you go. You'll be creating a new database. But since I already created one, I'm not going to repeat this. Once you define the virtual database, data virtualization operator will take care of the building or creating the Maven project, generating the Spring Boot code, including properties file, and then deploying it onto OpenShift. After some time, you will notice that you will have that particular database created. Now that you know how to create a virtual database, the next step is how you're going to interact with it. There are two ways. One is using olddata, which is a REST API. The other is using JDBC. This is how you're going to access the olddata interface. Click on Network. Go to Roots. Identify the virtual database. I got a few virtual databases here, so just identify this one. Click on this one. This is the base URL for the olddata. Olddata. When I do this, it's going to display the whole virtual database content. You see that the default is by displaying XML, which is too verbose for me, so I'm going to change it to format JSON. So it's much easier. And also what I can do is I can, for example, instead of just displaying everything, I can choose which column or actually which row I'm going to display. So if I want to display the ID 10, I just specify this one here. So just give me ID 10. If instead I want to list the top 5, so I can do this, top 3, for example. And that's how you're going to interact with olddata. And that's how you're going to interact with the virtual database using olddata. What about JDBC? Now, the easiest way to interface with JDBC, as I'm doing here, is using the Squirrel SQL client. And in order to connect to the virtual database, the easiest way is to actually do a port forward. So I'm just port forwarding, and this command here is to identify the port that is running this particular application, RDBMS-Union2, which is my virtual database. Once I do the port forward, this is port forwarding it to my local host, so I can actually connect from here. So connect. You can see here I have not added any security in there. That will come in the next video. You can see that it's actually given me access to the original database accounts and also the MySQL database HA accounts. So if I look at the content of the Postgres database, you can see there are multiple tables because I'm actually using that database for a number of different virtual databases. So, but for this particular application, I'm only going to use a customer zip table. So if you look at it, if you look at the content, there are only 3. And if you look at the MySQL database, there are again 3 entries in that particular table. But let's look at the end result of our data virtualization VDB. So if you look at the table, you see there's 6 entries. So it's actually combined the 2 tables from the external databases into one. And that's it for this particular demo on interaction with the virtual database. Now a quick recap. These are the topics I cover today. In the next video, I'm going to show you how I implemented use case number 2 using Spring Boot. So stay tuned and stay healthy. Thank you.